Hi, in this tutorial we have an exercise related to conformations of cyclohexane. The question in the exercise asks us, draw the structures of two chair conformations of 1/3 butyl 1-methyl cyclohexane on their chair templates below. Which conformation is more stable? Explain the reasoning. Let's start drawing the molecule, then let's explain which one is more stable and which one is less stable. Okay, here I'm going to choose one position here for this carbon, and we have to place a methyl and a third butyl. And we know that we have an axial and equatorial positions, and I'm going to draw the equatorial position like this, and I'm going to draw the axial position which is pointing downward. In the first instance, I'm going to choose the methyl group on the equatorial position and the third butyl group here on the axial position. So I'm going to draw third butyl like this. Okay, then we have to check the interactions between the groups on the cyclohexane, and we know that when we have an axial substituent, it will have 1,3-diaxial strain or interaction. So if this is the first position, this will be second and this will be third. And on the other side, we will have also a second and third. So there will be an axial hydrogen on the third position on this side. And also there will be another axial position on the other side. And the third butyl will have an interaction with these axial hydrogens, and we call this interaction 1,3 diaxial interaction or strain, and this is a steric strain. Type of interaction is steric strain. Basically, the bulky third butyl group will be interacting with the hydrogens sterically, and we will have a strain. This is the first, or let's say, A conformation. Let's have a B conformation. We know that cyclohexanes undergo ring flip process, and as a result of ring flip process, the axial positions will move to equatorial positions, and equatorial positions or substituents will move to axial positions. So number one carbon will be here now. If we flip this one up, so this is my carbon that will be pointing downward before the flip process, and we will have again an axial position and an equatorial position. Now, before methyl was in equatorial position, now it should shift to axial position, and the third butyl was in the axial position before the flip process. Now it should be in the equatorial position, and I'm drawing third butyl like this. We can also specify the methyl groups here, CH3, CH3, and CH3. Now, since the third butyl now is in the equatorial position, it will not have any diaxial interaction with the axial hydrogens, but now the axial methyl group will be having axial interaction. So if this is number 1, 2, and 3, so there will be an axial pointing upward hydrogen, and on the opposite side of the ring, also second and third carbon, we will have also an up axial position like this. And now methyl on the axial position will be interacting with these axial hydrogens. And we know that methyl is sterically less bulkier than third butyl group, so the strain here will be less than the strain on the A or in the previous unflipped conformer. So again, we have 1,3 diaxial strain here between uh, methyl and two hydrogens, and this will have less strain because of the smaller size of methyl and less bulky and less steric strain. Here, if the third butyl is on the axial position, we have here more strain. So basically, bulky effect of third butyl group. If we have less strain, it means that the molecule is more stable. So let's write this one. This will be more stable, and the other one has more strain and it is less stable.